You ever hit save on a document and just trust that it goes somewhere safe? Yeah, we all do. But have you ever stopped to think about where it actually goes? Well, today we're going to pull back the curtain on that little bit of digital magic. We're demystifying your computer's storage, that unsung hero that keeps all your files, photos, and projects safe and sound.
No, really, think about it for a second. You click save, it feels instant, right? But it's not just floating around in some digital cloud inside your machine. It's being sent to a very specific, very physical place.
And here's the thing, it's not just one place. Your computer is actually pretty smart. It has this whole layered system designed to organize and access your data in the most efficient way possible. It's not just a box, it's a system.
Okay, so let's get into it. The absolute best way to wrap your head around this is to imagine your computer as a digital office. You've got a desk for all the stuff you're working on right now, a filing cabinet for documents you need handy, and way in the back, a massive off-site archive for old records. This little analogy is going to be our guide.
So first up, let's just get a clear definition on the table. When we talk about data storage, what we're really talking about is the permanent, long-term storing of your digital info. And that word, permanent, is the key. This is the stuff that's meant to stick around, even after you've shut everything down for the night.
And you know, this brings us to something that people mix up all the time. The difference between memory and storage. They are not the same thing. Memory, which you probably know as RAM, is like your desk. It's temporary, just holding whatever you're actively working on. But storage, that's the filing cabinet. That's for permanent safekeeping.
All right, let's start where all the action happens, the computer's desk. This is the most immediate, the most active, and, you guessed it, the fastest part of our entire digital office.
So in computer speak, this desk is called primary storage. But like I said, you know it as RAM. The app you have open right now, the web browser you're using, the document you're typing in, it is all sitting right here on this digital desk, ready for you to access in a fraction of a second.
Now this desk is all about one thing, speed. It gives you absolutely lightning fast access to everything you're juggling. But, and this is a huge but, it's volatile. Think of it like a whiteboard. The moment you pull the plug, poof, everything on it is wiped completely clean. That's why having more RAM, a bigger desk, lets you multitask so much better. It's an amazing workspace, but it has zero long-term memory.
Okay, so if the desk gets wiped clean the second the power goes out, where do your files go when you hit save? Well, you move them from that temporary desk to the permanent in-office filing cabinet.
And this filing cabinet, this is your secondary storage. That save command, that's you literally telling the computer, hey, take this thing from my temporary desk and file a permanent copy away in the cabinet where it'll be safe.
And this cabinet, it is built to last. It's non-volatile, which is just a fancy way of saying your information stays put even when there's no power. Now, the trade-off is that it's slower to access than the desk, but your data is secure. This is where your computer's hard drive lives, or your super fast SSD, and any USB drives or CDs you might use. So we've got our super fast desk for active work and our reliable cabinet for our everyday files. But our digital office has one more room. A huge, vast archive for the things we almost never need, but can absolutely never, ever lose. I mean, just try to imagine it. Think about huge companies, scientific projects, governments. They generate these unimaginable amounts of data. We're talking decades of financial records, or patient histories, or astronomical surveys, stuff they might only need to look at once every 10 years. And here's the absolute crucial part. This is data they can never lose, maybe for legal reasons or for disaster recovery. So where in the world do you put all of that? You put it in what's called tertiary storage. This is basically the deep freeze archive of the digital world. You can picture these massive, secure, off-site data centers with actual robotic libraries that manage huge collections of magnetic tapes and optical disks for long-term safekeeping. And this is where the trade-offs get pretty extreme. The capacity is just astronomical. We're talking petabytes, which is thousands of terabytes, and the cost for every gigabyte is incredibly low. But the catch? Access is painfully slow. It might take minutes or sometimes even hours for a robot to go find a tape and retrieve a file. This is not for your vacation photos. This is purely for massive, long-term backup. Okay, so we've got our lightning-fast desk, our trusty filing cabinet, and a massive off-site archive. So let's put it all together and see why this whole tiered system is, well, kind of brilliant. It really all comes down to this simple hierarchy of speed and access. Your desk,
primary storage, is the fastest for what you're doing right this second. Your cabinet, secondary storage, is for all your everyday files and apps. And the archive, tertiary storage, is the slowest, but it's basically a bottomless vault for the long haul. Each layer has its own very specific job.
And that's the beautiful logic behind it all. This isn't just a random setup, it's a very deliberate system designed to strike the perfect balance between speed, capacity, and cost. It intelligently puts the data you need right now at your fingertips while keeping everything else stored safely and affordably. It's why your computer feels so fast and responsive.
You know, it's a really elegant solution for the world we live in today, but it does leave us with a pretty mind-bending question. As we as a species create more data than ever before at a pace that's just accelerating, what comes next? What will the digital archives of the future even look like? That's something to think about.